In this video, we're going to continue our talk about working with two samples and dealing with proportions, and expand what we did with confidence intervals into doing a hypothesis test where we're comparing two proportions to one another. First, a survey of Canadians reveals that 585 believe there's too much violence on television. In a survey of 1,500 Americans, 780 believe there's too much violence on television. Create a 95% confidence interval for the difference in the proportion of Americans and Canadians that believe there's too much violence on television. So, we've got a state. You can see I've kind of restated what we were asked to do. Again, we talked yesterday. Remember, this is doing the difference in the proportions. Okay, so we'll make a 95% confidence interval for the difference in the proportions of Americans and Canadians that believe there's too much violence on television. Now, in the plan piece, the first thing we've got to recognize is we had simple random samples, we hope, and that these two samples are independent of one another, meaning, knowing the proportion in one does not affect the proportion of the other. The next thing, we've got to kind of work both proportions separately. Let me do that real quick. Okay, so I've put in the conditions. Remember, the n must be less than or equal to 1/10 big N, the population size. I did that for both. And then we've got our sample size times our proportion. Sample size times 1 minus proportion. Make sure to write the numbers. They're both bigger than 10. And I repeated that for the American sample. So now we get to the do piece of this, where we actually do our two proportion interval. And we could say Z interval if we wanted, but let's build this with the calculator. Okay, so you find this in that good old test menu. And I just wanted to draw your attention to one thing, because in this example we were given data. We were given 585 out of 1,000, 780 out of 1,500. Occasionally someone will say hey, it was 29% out of 1,000, and you actually have to calculate this number. This number, the x's and the n's must be they must be like counting numbers, meaning if there had been some round off, let's say they told you a percentage and you calculated and came out with 81.1 people, you should write 81. These numbers must all be whole numbers, okay? So make sure and do some rounding or you get a domain error. All right, let's calculate. Here is our calculator output. So our interval is 0.025. and 0.105. So let's conclude. So we are 95% confident that the interval from 0.025 to 0.105 captures the true difference in the proportion of Americans and Canadians that believe there's too much violence on television. So this is a process we've been through, and I think it's pretty straightforward. I just wanted to flip this to for 1 second to be the idea of a hypothesis test. Imagine for a minute that instead of making a confidence interval, I said, is there statistically significant evidence that the proportion of Canadians and Americans is different? So you'd think your null hypothesis would be that there is no difference. Your alternative would be that there is a difference. And then I would ask, just based on your confidence interval, to tell me reject or fail to reject. And the answer based on this confidence interval is rejection. And the reason is we're 95% confident, so at that 0.05 significance level, that the difference between the proportions is positive. 0 is not an outcome inside of our interval. And if the null hypothesis is that the two countries feel the same, that means there isn't a difference. But our confidence interval signifies that there is a difference, that one has a higher proportion than the other. So this is just an idea of how we could use a confidence interval to really do a hypothesis test at the same time, which leads us to talking about hypothesis tests. Time magazine reported the result of a telephone poll of 800 adult Americans. The question posed of the Americans who were surveyed, should the federal tax on cigarettes be raised to pay for health care? The results of the survey were, you can see the non-smoker numbers, sample size, percent or number that said yes, and a p-hat. You can see that same information for the smokers. Is there evidence at the 0.05 level to conclude that the two populations differ significantly with respect to their opinions? So, this just saying differ, we're going to run this as a not equal to. Okay, so our null is that the proportion of non-smokers is equal to the proportion of smokers. Our alternative is that they are not equal. Now, I'm sorry for my poor handwriting here, but here's a nice thing about using the subscript, and it's something that we can now begin using with two samples. We don't need to define the parameter. The AP exam says this is okay because you're using proportions and you're telling us what those proportions represent. Okay? Another way to write this that you'll see in some textbooks is, and let me just shorten it a little bit, proportion of non-smokers minus proportion of smokers equals 0. Proportion of non-smokers minus proportion of smokers is not equal to 0. You'll see some textbooks do it that way, where they like the inequality to be, something like in relation to 0. Both are accepted. You obviously don't need to write both. Okay, so pick one method that you like and kind of stick with it. So here is our state step. Now let's do the plan. Okay, I put in the those conditions in the plan part. Nothing has really changed from our work on confidence intervals. Remember, we need simple random samples. We need them to be independent samples of one another, and even though we drew from the same 800, we separated them into two groups that we then took information within groups. So the proportions, just because 351 non-smokers said yes, that really doesn't, that's independent of what the smokers said. So they're independent. I did the 1/10, the 10% rule, NP, N times 1 minus P for both. It all checks out. So let's do the do portion of this. Okay, so you can see here, we'll go into our test menu to two proportion Z test, and we'll put in our two proportions. Now, I should just say, we had in a way a little bit easy here that we are doing a not equal to. Make sure, that when you set up your proportions in your null, that they face the way you want. If you want the non-smokers to be greater than, then make sure you put non-smokers here, smokers here, and then put a greater than. Okay? So, make sure that you kind of check your work as you go so you're not accidentally having the inequality facing the wrong way. All right, so I'm going to hit calculate on that. Okay, so here you can see our test statistic and our p-value. I want to remind you of one thing. In a two proportion test, we should write down what we did. Test. We use Z. We had this kind of added condition, of NP and N times 1 minus P having to be greater than 10. So therefore, we're using a Z test. So there are no degrees of freedom on this. Okay? So the one last thing I'll call your attention to here is this P at the bottom. You have our proportion 1, proportion 2. This is a pooled proportion. So if you actually added up the 351 and the 41 and divided that by the total 800, this is the total pooled proportion that said yes. That's not really any information we need. Okay? All right, let's do the conclusion for this. All right, so we will reject the null because our p-value is below 0.05. We have evidence that the proportion of non-smokers who support raising the tax on cigarettes is different than the proportion of smokers who support raising the tax. So again, just remember, same old, right? Tell what you did, why you did it, and then put it in context. So I don't think there's anything too earth-shattering in this two-proportion Z test. It just adds a little bit more to our work with working with multiple samples.